I am on page 82. We are starting into the trigonometry section. And when you turn to page 82, you'll notice that your page is different than mine. I have added some little notes here that I'm going to use at least for the first few problems. I will eventually stop using the calculator buttons, but we will definitely want to keep this variable box. So in this box, you'll notice that I have the letters H, O, and A. That stands for hypotenuse, opposite, adjacent, and then I have theta, which represents the angle. And then these boxes I'm going to use for calculator steps. So we'll use those in just a minute. You will need a calculator, a scientific calculator, to do these problems. A standard calculator will not work unless you have the memorized ratios for the different angles. But you will need a calculator to do this one. Okay, here is our problem. A radio tower is supported by a wire that makes a 55-degree angle with the ground. So this is my tower. Here's the wire, and here's the ground. It's really important to understand the problem before you start to do this. Okay, theta is going to be right here, and in this case, theta is 55 degrees. So theta is given. We know that the wire is 80 feet long, and they want us to find the height of the tower. So we're looking for this dimension. And let me move this over. This is the tower. So let's use our colors, at least for a few of these. Here is adjacent. It's adjoining theta. Here is hypotenuse across from the right angle. And here is opposite across from theta. So those are the pieces of this puzzle as we've learned them. We know H, we know hypotenuse is 80 feet. We are looking for O. We don't know A in this problem, and we don't need to. A, the adjacent side, the ground, is not relevant to this problem. So we know H and O. And let me just circle that with a different color. That is going to tell me in SOHCAHTOA which ratio I need. I don't know if we're going to find any cosines in these problems. We might, but most of these will be sine and tangent. But this one has O and H, so that's going to be sine. The sine of 55 degrees, sine of theta, is opposite, which we don't know. I'm going to use a T for tower, over hypotenuse. And we're ready to solve. I want to get rid of that 80, so I'm going to use its reciprocal. Remember, a reciprocal will allow you to cancel fractions. And if I do it to one side, I must do it to the other side. So I will also have to multiply this side by 80. So this will cancel. That's what we wanted. And we're left with T, the tower, being 80 times the sine of 55. Now to put this in your calculator, you will do all clear. 80 times 55 sine. We're using the sine ratio. And you must press equals. If you don't press equals, you will only have the sine of 55, not the answer to the problem. So make sure that you press equals. And that leaves us with 65. And we need to decide how to round. I think I did hundreds. Let's do hundreds. So 65, and I've already cleared it, 80 times 55 sine equals 53. And that is approximately the height of the tower. You always want to include your units. So your answer is going to be 65.53 feet. A person stands 30 feet from a flagpole. So here is the flagpole. The person is over here. And they tell us that this dimension is 30 feet. And looks up at a 60-degree angle. So I call this line of sight. This is the person's line of sight. It's also the hypotenuse in this problem. How high is the flagpole? So we want to know the height of the flagpole. The flagpole is opposite. It's across from theta. Hypotenuse in this problem is the line of sight. It's the slant. And the ground is adjacent to theta. So let's fill in our variable box. We know that the ground is adjacent. That's 30 feet. We want to know the height of the flagpole. That's opposite. So this time we're dealing with O and A. We also know that theta is 60 degrees. So this time we want TOA. We know O and A. So we want the tangent of theta is equal to the opposite, which we don't know. I'm going to call it F for flagpole, over the adjacent side. We do know. And this time I'm going to multiply by 30 to get rid of that denominator. I want to isolate F. So F is going to be 30, all clear, 30 times 60 tan for tangent equals. So we have 30 times 60 tan equals about 51.96 feet. And that's about right for a flagpole. Always ask yourself, is the answer reasonable? 51, 52 feet for a flagpole, that's reasonable. And I forgot to mark the O and the A for you, but that's what tells me that I want to do tangent. Hypotenuse is not a factor in this particular problem. All right. A bridge support cable makes a 70-degree angle with the bridge and is 120 feet long. Find the horizontal distance from the base of the cable to the bridge. So our bridge is going to be which of these sides? It's this one. So bridge is opposite. The cable is hypotenuse. And they also tell me that the cable is 120 feet. They tell me that the cable makes a 70-degree angle with the ground. So that is theta. And then they also mention the horizontal distance. Horizontal is left to right. From the base of the cable, that's this point, to the bridge. So this is the horizontal. And that's what we're looking for. That's the part they want us to find. So we know hypotenuse is 120. We know the horizontal is adjacent, and that's our question. And we know theta is 70 degrees. So we are going to need cosine. We know h, and we know that we want to find a. So those two, the HA, will give us ca. Cosine of theta is equal to adjacent, that's the question mark, I'm going to call that the H, the horizontal, over hypotenuse, that's 120. And we're ready to solve. So we want to cancel away that 120 on that side. That will leave us with just H. And then we can solve. We know that we want to say all clear always first. Then 120 times cos, sorry, I'm used to a TI, 70, and then cos. Don't forget equals. You got to put the number before the cosine. So we have all clear 120 times 70 cos equals about, we're having to round, 41.04 feet. Or we could say about 41 feet. You can round it unless you're told otherwise. You can round. Okay, this one is a little bit tricky. This one is asking us to find secant. I did not realize that there was one of those quite so soon, but that's okay. We can do it. Let me remind you. Let me think here. Let's turn back just a second. Let me see which page I want you to turn to, because we need to talk just a minute about secant. It's going to be page 6. It's back in your formula section. So if you go back to page 6, you're seeing behind the scenes of my notes. That is not page 6. Here we go. We're looking at secant, and I'm going to take just a screenshot of this, if I can. Take screenshot, and I want to copy that. Okay, so I went back to page 6 in the formula section, and I found that. So I'm going to go back to page 82. Sorry, if I had realized it, I would have already had this copied in, but I just didn't. So let's paste that for just a second. We're going to need this bit of information. A Ferris wheel has a 50-foot radius. So first of all, let's get a really good grip on what we're talking about here. If this is a Ferris wheel, like you might find at Dollywood, you get on the Ferris wheel turns around an axis. It turns around a fixed point, that is the center. So it rotates, or it may go this way, but it turns around that fixed point. The radius from that point to the seat on the Ferris wheel is 50 feet, which means this would also be 50 feet. And there we have opposite and adjacent. Here's opposite. We're going to put theta right here. And then here is adjacent. So indirectly, they're giving us the pieces of a right triangle. And this distance would be hypotenuse if we needed it. So if you use your variable box, we can go ahead and fill that in. We're not going to need the variable box, but let's fill it in just to be sure of what we're doing. Hypotenuse, we don't know, we don't care. Opposite is 50, and so is adjacent, because this is a circle. And both of those are radii for this circle. We also know theta. We know that theta is 30 degrees. So if you were looking at this angle would be 30 degrees. But this says to find the secant of a 30-degree angle from the center. So we need this formula that I copied and pasted from page 6 that tells me that secant of theta is defined as hypotenuse over adjacent. Okay, so we could use that one. But there is another one that we could use that would be much more productive for me here. In fact, I'm going to take this away. I also know that secant is the reciprocal of cosine. And that's how I'm going to solve this problem. I'm going to say that the secant of 30, the secant of theta, is equal to 1 over the cosine of theta. That's the reciprocal part. So the secant of theta, which is what we're looking for, is the same thing as the cosine of theta, and theta is 30 degrees. So you might be asking me, well, Miss Amanda, why don't I just put secant of 30 into my calculator and I wouldn't have to go through all of this? It's because this particular calculator that we're using will not do secant. Some really advanced calculators will, but this calculator will do cosine. So here's what we need to do. In the calculator, we're going to put in this part. Okay, that's the part we're going to plug in the calculator. So we're going to say all clear. 1 divided by 30 cos equals. All clear. 1 divided by 30 cos equals. And there's your answer. The secant of 30 degrees is about 1.15. And that's the answer that we're looking for. I don't want you to stress about this problem. If you understand all of the problems that we're doing, except this one, you're okay. I didn't realize that this crept in here. So I apologize. I should have caught it before now. But if you have to do a secant problem, this is how you do it.